Hi everybody, this is the Math 10C Trigonometry Review, and this is multiple choice 12. It says determine the length of line segment RS, okay, to the nearest, sorry, that should say 1/10 of a centimeter. I'll fix that in a second here. Now, in order to do this, let's take a quick look at the diagram here. Okay, we'll just zoom in on this a little bit more. Notice we've got two triangles back to back. Now, these kind of multiple triangle problems are actually really common here. What we're being asked to figure out is the length of RS. Now that's of this triangle right here. Notice that we've only got 2 bits of information about it. We've got this side, this angle right here, this angle right here. We don't have enough information to determine that just based on what we've got right here. However, I have a few bits of information on this triangle here, QRT. That's enough to help me figure out this piece that is shared by both of them, because that's really what I'm interested in. Okay, I just need one more piece of information from triangle RST. Okay, I don't have it, but I do know that it shares that one line there with triangle QRT. So if I can figure that out from this triangle, I'm good to go here. So now, look at triangle QRT. We've got this angle right here, this 39 degrees. That's important because that identifies the sides that I'm given and the side that I'm looking for. Okay, so based on this angle, this side here, QR, is going to be opposite. And then because x that I've drawn in here is opposite the 90 degrees, this is my hypotenuse. So I'm looking for the hypotenuse. I've got the opposite side here. I got to think what trig ratio relates those two, and the answer is that it's sine. So the sine of 39 degrees is going to equal the opposite, the 8.9, over x, the hypotenuse. Okay, now how do I get x out of this? Well, I'm going to multiply both sides of the equation through by x. That unknown represents the hypotenuse. On the right-hand side, it will just cancel. But on the left-hand side, I will get x times the sine of 39. Now what I want to do is I'm going to divide both sides here by the sine of 39 degrees to get that over there. So x is going to equal 8.9 over the sine of 39 degrees. Okay. So I will do this on my calculator, 8.9 divided by the sine of 39 degrees. Okay, and I'm going to get out of this 14.1422, and so on and so forth. I'm going to leave that number in the calculator for right now because I'm going to come back to that in just a moment. Now let's take a look at the next triangle. Okay, I know that this angle right here, I've also got the hypotenuse now. I just figured it out, and what I'm looking for right here, and maybe we'll call this y here, I am looking for the side adjacent to that 54 degrees. Now I know the hypotenuse of that triangle, I just figured it out, and I'm looking for the adjacent side. The trig ratio that relates those two is going to be cosine. So the cosine of 54 degrees is going to equal, in this case y, the adjacent side, over my x. Now I know that that's going to be 14.1422 and so on. I'm leaving that number in the calculator. I'm not going to round until I'm done. That will be my very last step. To get the y by itself, I will multiply by that 14.142 and so on. So on the right-hand side, that's just going to leave me with y. Over here, I'm going to get 14.142 and so on times the cosine of 54 degrees. And now, when I just multiply those two together, I get 8.3 as my y value. And now remember, that's my RS. That's what I was looking for. And so now I just look, I'm going to zoom out here a little bit. I just look at my possible solutions, and it looks like my answer is actually D. There we go. Like I said, really common sort of question to put two triangles together and force you to use the one triangle to find the piece that's shared to find another piece of the far triangle.